Sorry about that, guys. Okay, so I'm Richard Myers. I work for Gotenna. Gotenna is a company building next-generation mobile mesh networks for truly decentralized communication. And today I'm going to show you some of the ways that this technology can be used to make your Bitcoin transactions more unstoppable. Keep with the theme here. So what is a Gotenna? This is a Gotenna. Gotenna makes the world's first consumer mobile mesh networking device. And the Gotenna powers a network focused on short burst communication over very long range. And it allows you to communicate without satellite, Wi-Fi, or cellular coverage. So when you're using a Gotenna, messaging is free, and it allows you to create an end-to-end encrypted communication channel with anyone also running the Gotenna. It uses the UHF band, which is also called the IS7 band, and it's as easy to use as your normal messaging app, but it uses a completely peer-to-peer transport layer, so it'll work when nothing else will. The company was actually, the story about when the company was started was the founder actually was partially inspired by her experience during 2012 when Hurricane Sandy knocked out a third of the communication in infrastructure in a 10-state area in the US. So how does a Gotenna work? So with a Gotenna mesh, you're basically sending messages directly from your device to somebody within range. And if the person you're trying to communicate with is outside of your range, then it's going to hop from node to node to node until it reaches the destination. So we're basically turning the density of Gotennas into capacity of communication. And this is all handled automatically by Aspen Grove protocol, which handles the routing between nodes so that your message is delivered. This is very similar to the Bitcoin network. So this is showing Bitcoin nodes. And like the Gotenna mesh or like a mesh network, there is no central organizer of communication between nodes, Bitcoin nodes. There's no special infrastructure for that. And that's also true for the Lightning Network. It's also a flat network. But unfortunately, these flat networks are really just overlay networks on a centralized internet, which depends on carriers that are very centralized. So this is despite the fact that even if you want to send an SMS or an instant message directly to somebody nearby, it's going to go to a base station somewhere out there, and then often to an internet server, so a server somewhere on the internet, and then coming back to the person you're delivering to, despite the fact that your cell phone actually has the technology or is capable of communicating in a meshed fashion. But the people who are licensing the bandwidth for your mobile phone, they have no economic interest in allowing you to communicate phone to phone. And at best, you can use Bluetooth to create a local mesh, which is really not very practical. Now, there are solutions that we talked about in the panel that are coming to help alleviate this problem. We talked about satellites. There's also long-range radio. But for a local community, we have mesh. So last October, the Samurai Wallet team developed an application using our open SDK called TXTenna. And what TXTenna lets you do is take a raw transaction and broadcast it over the mesh network. And this is part of their Mule Tools project, which is an open source collection of tools for sending raw transactions other than using the normal internet. So a little bit about the Gotenna. So it has a range of between 1.6 and 6 kilometers, something on that order. Depends a little bit on the environment. It's packaged with 24-hour life battery. It's very light, 48 grams, but it has limited bandwidth. But fortunately, Bitcoin transactions don't need a lot of bandwidth, and so a few transmissions is all it takes to get a Bitcoin transaction over the network. Some users have shown that, so this is CoinShare from New Zealand, and he's done some great sort of tests of this technology where he was able to show us transaction being relayed over a couple of, it's got 5 and 7 kilometer hops. And he also cleverly hid the relay up in trees. That's just showing that it's so small that you can hide these sort of anywhere. And we've got other users who are trying various tricks. So some people in the community are trying to loft them in the air to get better range. Other people have actually voided their warranty and added antennas and batteries and solar panels to also create fixed stations for increasing the coverage of the network. The real advantage of something like this mesh technology, though, is that it allows you to, it has great range. And with great range, it allows you to have fewer nodes and lower cost to create a fully connected network. So as few as 25 nodes in a 5 by 5 kilometer region is approximately what you would need for a fully connected network. And other network technologies that could create a mesh would require orders of magnitude more expensed and hundreds of units to have the same level of coverage. So I'll give you a brief overview of how it works, and then I'll show you a demo of it working here. So on the left-hand side here, you see there's a phone sends a transaction, creates a signed transaction, and that's relayed from an off-grid node. So this would be a phone without any sort of mobile coverage. And then it's going to send it over different Gotennas that are relaying. And those Gotennas don't have to be running any special hardware. They always relay anything that comes across. When it reaches a node that's running TX10 but is on the internet, it will then it will send it to a full node, which will mine it into a block, and then the receiver can actually check that. The node will also send back what I call a return receipt to the original sender. So even though they're off grid, they can get some indication when that transaction is on the Bitcoin, has been sent to the Bitcoin network, and also, again, another message when it's confirmed on the Bitcoin network. So that's just to let you know that your communication was successful. And again, this was made with our open SDK, so that any of this can be changed and modified by the community. And another technology I'll show you here in the demo is called TX10 Python. So it's basically just the protocol that is in the MuleTools app on the phone, but translated to Python. So you can, this is an example of running it on I'm going to run it on my PC here, but you could also run it on a single board Python, single board Raspberry Pi or something like that. And you could use that as like a home receiver for your Bitcoin transactions. If you're off-grid. Actually, there's two ways. It could either be, you could use it as a gateway to the internet that you run, or you could also use it if you're running an off-grid node. So for instance, if you had a satellite dish giving you your blockchain information and you wanted to send a transaction off-grid from a completely off-grid system, you could also use something like this single board computer, which is very low power. And the goal, just, we talked about this in our panel, but you want to route around censorship and also obfuscate and break that physical link between the sender of a Bitcoin transaction and the transaction itself. So your GID, the identifier, doesn't physically connect you. So now let me show a demo here. Let's see if this works. Okay, maybe it's back here. There it is. So that's my phone. And this, I don't know if that's too small to see. I can make it a little bigger. Okay, so what's running here? TX10, that's this blue one. And then what's running on the phone, what's going to be Bluetooth connected to the phone, is the green one here. And you can kind of watch the lights. They're obviously very close to each other, but they could be kilometers apart, and this would still work. So here I've already sort of teed up a transaction using the Samurai wallet. And I'm going to send that. And even though I'm connected to the internet here, because I need to talk to my computer to show this. Oh, okay, yeah, there you can see it. So even though I've got internet connectivity, there's a mode in the Samurai wallet where you can have it not put transactions on the internet. So it's going to give us an alternative when I send the transaction. Okay. Oh, wait a minute. Yep. Okay, so it's creating, then it's going to sign it. And now where it would normally send it to the internet, it's going to give us the option to send it over, either show a QR code, so you could do it in person, but in this case we're going to send it over the TX10 app. So this light, if you can't see it there, but it's now connects to the radio. So then when I'm just going to give it a minute to get ready. And I send it, and what it's showing you here, this is what's actually sent in each packet as it's sending it over the radio. And this is going to take a few minutes because, again, it's low bandwidth, and we also rate limit it, so if a lot of nodes are working in one place, they can sort of share the bandwidth. And it could be 3, 4, 6, 8, it could be up to 10 different transactions. You can see I've got some previous transactions that I sent when I was testing earlier today. So that was the second segment of it. And if you want to go to the radios, you'll actually see one blinks and then the other blinks, so that's showing that they're communicating. It's a little bit like watching grass grow. There you go, there's one. And the other one, the slow blink, is the receiver. So you see something happening there. So right now you'll notice it says, if you go back to the screen for a second, it says relay to the Gotenna Mesh Network. So that just means it knows it's broadcasted, but it hasn't gotten any receipt to know that it's been received. Because you're not sending to a particular receiver, you're just broadcasting this to anybody. You don't know if there's anybody out there who's going to receive it. We do because I'm running it, but otherwise you wouldn't know. So there was another one that just went through. And once it gets them all collected, the computer, which is running the server connected to the internet, is going to put them back together, put the segments back together, and then submit it to the blockchain. So we have to wait a little bit here. We probably won't wait long enough to get a confirmation. I think I should have paid a higher fee. But we might get lucky. You never know if I wait long enough. So still waiting. I think hopefully the communication here is working. I know the internet's been a little flaky, and that is required, at least on the receiver. Okay. Something will happen here, I hope, soon. Oh, something just happened. Okay. So, there, yes. So delivery confirmed. So that's the computer sent a message to the phone, a private message in this case, saying that it's been broadcast to the Bitcoin network. So that's probably all we'll see in this demo, but if we waited another average of 10 minutes, you'll get another message back from the server that says it's confirmed on the Bitcoin network. So I'll just show you. Again, you wouldn't normally be able to do this because you don't have internet, but here we've got internet. So we can just see that it's now on the Bitcoin blockchain. No, maybe we can't. Let me try another one. This was the one that I did before. So this was the one I did earlier today. Let me go back and just see if the Explorer has caught up. There it is. So that's the one I just did. So it made it onto the Bitcoin blockchain. So if I was the receiver of that transaction, I'd be able to see that it was at least in the mem pool. And then in an average of 10 minutes, I'd be able to check and it would actually be confirmed, I hope. So that's it. It actually goes pretty quick when it works. Don't think there's anything else I wanted to say about that, except for the fact that this is only, this was first released in October, and we're still building on and still adding features. So if you try it, especially if you try it tomorrow and you have feedback, definitely let me know if there's something you'd like to see, and we can get it done. All right, thanks.
All right, thank you so much. We can maybe take some questions as Valerio sets up for the next demo. So if you want to unconnect as the next speaker connects, and if anyone has a question, come on up to the mic or up here.
Okay, not yet until you try tomorrow.
Right.
Good.
I'll be here tomorrow.
Oh, we have the location for the drinks tonight. That's going to take place at 8 p.m. So that's at 8. And it's also in the Telegram group chat. But
a question? Okay.
Club lounge? Or is there this club?
You finished, Sam? Yeah. Yeah. I'm going to ask you because I know we talked about it before, but what's the current status of your thinking on incentivization of the mesh network?
Yeah, thanks for asking about that. I didn't really talk about it today because it's a little complicated, but it's a good question. And I don't know if when we had our panel, we got a little bit into that. It was interesting to hear Adam's thoughts on that and that they had explored that as well. It's something that we're still planning to pursue. I do believe it's not going to be like a direct port of the Lightning Network translated to mesh. It's going to have to be something a little more complex. And my thinking is also along the lines that, we may have to make some bandwidth sacrifices, like it may not be able to be the most efficient protocol possible, but it's probably going to still require things like Schnorr and L2 in my mind.
Are you still thinking about BLS or?
Well, I'm a little more bullish on using Musig and Schnorr right now.
Okay.
I think I'm sort of convinced that the difference in signature size may not be that significant compared to trying to make your own chain. I mean, RGB isn't ready yet for me to make my own, side chain for something like this. So I think that if we could do it with Musig and we could do it with Schnorr, that would actually be the best way to go forward. So
Musig does have the sort of 3-round interactivity issue, or 2-round depending on if you want to.
Yeah, and I talked to some people in Boston recently, and we think there may be a way to do that where we can pre-configure that and maybe get around some of that. So this is still very much a work in progress, but I'm glad you brought it up because anybody who's interested in this, I'm really looking for feedback, and I'm really hoping to be able to push this forward over the summer. So thanks, Al.
Thank you.